Hello, this is Zeke Rogers with YOUnite, and today I'm going to give a demo using a popular graph database called Neo4j with YOUnite. Graph databases differ from relational databases in that they focus on the relationships between data rather than just the data itself. They're also flexible to changing data, similar to a NoSQL database, and they have better performance than traditional relational databases at handling data relationships. Popular uses include search engines, recommendation engines, fraud detection, and I'll show here too a simple organizational graph, MDM style organizational graph. For this demo, we're going to add a graph database into a YOUnite implementation to provide additional insight into the data. We have 3 zones with 5 databases that are synchronized through YOUnite. We have an Oracle database in the Asia zone, a Postgres database in the North America zone, and SQL Server and MySQL databases in the European zone. In addition, we've added a Neo4j database to the North American zone. The Neo4j database ingests the same data events that synchronize the other 4 databases, creating and updating its nodes and relationships in real time. Note that we're using a Kafka stream here to get the data into Neo4j, which I'll discuss a bit more later. Okay, so for this demo, we're going to talk about an organization that sells products to customers. The diagram on the right shows the relational data model from the source systems. When a customer buys a product, a purchase order is created. The purchase order contains 1 or more sale items and is serviced by a single employee. Using Neo4j, we can use this data and its relationships to create a recommendation engine to recommend products to customers based on what other customers bought. This diagram shows how data moves from one of the databases, in this case Postgres, through YOUnite, Kafka, and finally ends up in Neo4j. For example, when a new sale is recorded, the database adapter detects the transaction and sends a data event to YOUnite. YOUnite runs the data event through its data governance engine and determines that the Kafka adapter should receive the data event. The data event's routed to the Kafka adapter, which posts the data event to a Kafka topic. The Kafka Connect sync for Neo4j reads the data event from the Kafka topic and converts it to a query, which is executed on Neo4j to add, update, or delete that record. The query that is executed is defined in the configuration of the Kafka Connect sync for Neo4j. This process all happens in near real time. All right, now I'll log into the YOUnite UI. This will just give us a quick peek into how everything is set up. This is not meant to be a tutorial of the user interface. For other videos on that, check out our website, younite.us/articles and videos. Just quickly here, I'm going to go through and just show you some of the things I mentioned in the slides. So here are the 3 zones I mentioned. We have Asia, North America, and Europe. And then here are the domains we have. The domains correspond to the tables in the database. So we have a customer domain, employee, product, etc. If you click on a domain, you can see the details of the data model of the domain. So the customer has an ID, first name, last name, etc., etc. Now let's go to the adapters itself. Actually, let's switch to the North American headquarters because that's where the Kafka adapter is, and we will go to the adapters page here. So notice we have 2 adapters. We have the Postgres database right here, adapter, and then we have the Kafka adapter, which is going to stream the data events to Neo4j. Notice it has some metadata here, which was generated with our wizard to configure this adapter with the tables that it's capable of handling, what the Kafka server address is, and some other details. We can also see on this tab capabilities here what domains this adapter is capable of receiving data events for. So in this case, they're all turned on here. Put, post, and delete are kind of like your REST they're named after the sort of REST API endpoint. So a post means a new record, a put means a update to a record, and delete means a deleted record. And get is not checked here because this adapter only receives data events. It doesn't allow us to retrieve data from Neo4j. So the data is only going in one direction. It's going from YOUnite through Kafka into Neo4j. We'll go ahead and show two other features really quickly to show just that the Kafka adapter here is just like any other adapter in our system. For example, we can apply data governance to this adapter. So here I defined an inbound ACL, which means data events coming into this zone. And I'm saying data events from any zone, any adapter for customer. And then for these two properties, birth date and phone number, are restricted to the Kafka adapter. What this means is that when a data event comes in, the birth date and phone properties will be stripped out and will not be sent to Kafka. So this could be done for privacy reasons, for example, but just a quick example of setting up an ACL for this type of adapter. I'll also show that if we go to the data access tab, here's a list of our customers that have passed through YOUnite. We have this lineage feature that shows the lineage of this record. Like where did it come from? What operations have happened on it, etc. So we can just really quickly here see that this post event came in, which means a new record from the North America database. We can see it was originated, so this is the origin of this data event, and it was routed to these four adapters, including the Kafka adapter. Okay, before we get into Neo4j, briefly, I want to show you what the data looks like in the relational databases, the source systems. So this is the Postgres database. You can see I have the employee table right here. So, this is your standard, relational table. We can see the employees' names, emails, their data is laid out like this in a table. We got customer, here's the purchase order information, here's a sale, with the price, quantity, discount, product information. So just real quick to show, this is where the data is originally coming from. And when data is added to or changed in this database, it will be detected, sent to YOUnite, and then routed to the Kafka adapter, which sends it to Neo4j. All right, now we're going to jump into Neo4j. This is the Neo4j browser, which comes with the product. If I click here over on database information, it has this cool little dashboard here. It shows you some of the node labels, which correspond to our domain names. So we got customer, department, etc. And then relationship types, works in, like an employee works in a department sells a product, that sort of a thing. Let's go and just click on one of these. If we click on department, it shows the four departments of this organization. So this is like retail. So we have clothing, shoes, jewelry, and accessories. You notice if I hover over one of these nodes, it shows you the data of that record. We can also look at it in table view, which shows just the data of each record. All right, let's check out a relationship type. Let's check out works in. Let's go look at the graph first. This graph shows all nodes that are related by the relationship works in. So we can see this person works in jewelry. And we have some other departments over here, shoes, accessories. So we see all our employees and everywhere they work. One thing, relationships have properties also. So notice when I hover over the works in relationship, it shows us something now called role. In this case, this person is the product buyer. This is the manager. So I can actually, in this browser, can configure what the graph looks like and change the label to role instead of the name of the relationship. So now we can see these relationships. You can see the name, which is pretty cool. All right, let's try a more complex query here. Let's do a simple query here. Let's see a graph that includes the works in and sells relationships. So this is the cipher language that Neo4j uses, and basically what this is saying is just these parentheses here are saying that that's a node. We don't know what it is. We don't care what it is, but what we want to see is that there are nodes related by either works in or sells. So let's execute this. And what this is going to give us is sort of our organizational chart here. So notice that we have the jewelry department. We have the green bubbles here are employees, and then these ones are the products. So jewelry, this person is a sales associate in jewelry, and jewelry sells an emerald bracelet. Down here, we can see the same types of things. We can see there's some interconnection here. This person works in two different departments. So just kind of one of the cool visualizations you can get with a graph database here. All right, so let's go back to the database. And one thing I want to show is that if we make some changes to the database, it'll be updated in near real time in the Neo4j instance. So we're in the employee table here, and I'm going to change Eileen's name to Sharon. Let's save that. And now if we go back to Neo4j and rerun the query, we should see that change. All right, so I reran the query, and we can see here now, here is our Sharon McGowan. So it was updated in near real time, within a matter of seconds. This information was moved through YOUnite and went through data governance and went through the Kafka topic and arrived here in Neo4j. What we want to develop for this demo is a product recommendation engine. So I have this query. First, just to kind of start us off, let's identify customers who bought a particular product. So let's say, for example, what we're looking for is that when a customer buys a product or when they add that product to their shopping cart, we want to recommend products that other people who bought that product were also interested in or who purchased. So I'm just going to run this query. I'm limiting to 25 results so that the graph's not too big. What I wanted to show you is what this picture looks like. So it's interesting. We got the customer here. We have the relationship to the purchase order, which has an item, and then eventually we get down here to the product, the hiking boot. So it's cool we have all this data, but really we don't care about the purchase order. All we want to know is what customer purchased what item. So what I'm going to do is I'm going to create a new relationship so that we don't have to worry about all the purchase order information. So what I'm doing here with this statement is I'm matching customers who all the way through the relationships to the product here, which is P. And then the merge statement here says to create or update this relationship. So C bought P, customer brought product. Okay, so that created 1,650 relationships. Let's take a look at what that looks like now. We'll do the same query, except now we'll use the bought relationship, and I'll limit it to 25 again. So now, if we look at this one, we can see it's much closer to what we want. We're able to see that this person bought this product. So now that we have these nodes related to each other, we can write some pretty powerful queries really easily to see what other products they bought. For people who bought the hiking boot, let's find out what other products they bought. So again, here I'm doing a match on a hiking boot, what customer bought it, and then I can look for relationships, another bought relationship to another product. And I'm going to use the where clause here to exclude the hiking boot from the result itself. So graphically, I'm just going to pull this up graphically at first, just for fun. It's an interesting picture we get here. You can see that the hiking boot is at the center of the graph, and the customers are bubbles all around, and other products are kind of, in here. Some have more arrows going to them, some don't. So this is cool. But what we really want to know is, okay, what product should we recommend to them? So let's do an aggregate on this. So now I'm going to return the name of the product and then the number of hits we got. All right, so notice that this comes back as a table. At the top here, we got hooded sweatshirt, high top sneaker, and signature shirt. And we ordered this in descending order. So those three would be our top 3 products to recommend. I'll do one more query here just to show a slightly more complicated example. We're going to look for customers who bought 2 products. They bought the signature t-shirt and the bomber jacket. And then we're going to come up with recommendations for that. So here we got the high top sneaker was the top hit, then the classic sneaker, then designer jeans. What's cool about this is if you look at the query, it really is much less complicated than if you were going to write something similar in a SQL database. And it's really just all about the relationships here with the bot relationship. All right, that's the end of the demo. Thanks for watching. For more articles and videos, go to our website.